Hey everybody, it's Mr. Glover here. Figured I would post an extra video here, just talking about some of the topics from the last set of notes. We haven't had any content in a while, and I figured it might be a good thing to see a little bit more and to go through some more problems. So this would have been a warm-up that we would have done. There's two questions. There's question one, which is a composition of functions problem. We're going to have to join some functions together, find their domains and ranges. And then problem two, we're going to use a table of values to figure out what some composite functions are. So going up to question one, given that f of x is x squared plus 3 and g of x is root x plus 3, find the following functions and state their domain and range. So we want to find f of g of x. We start by writing f of x and we put brackets where x was. So f of x used to be x squared plus 3. So we can write bracket squared plus 3. And then in the brackets, we'll put the inner function, which is g of x, root x plus 3. At this point, we're going to have to square root x plus 3. But before we do that, we need to think about our restrictions. So the square roots can't be negative. So x has to be greater than or equal to -3, or else we will have a negative in our square root. So when we go ahead and we square this, it will become just x plus 3 plus 3. We need to keep in mind that x had a restriction that it's greater than or equal to -3. And we can go ahead, we can finish this problem off. X plus 3 is going to be x plus 6, given that x is greater than or equal to -3. And the last thing you're going to want to do is you're going to want to sketch it to find the range. We probably don't need Desmos for this one. It had a y-intercept of 6 and a slope of 1. So it should look something like this. And the values below -3 don't exist. So wherever x is below -3, that's going to be gone. If we want to figure out what y value that caps it at, we just have to put -3 into our equation. -3 plus 6 is 3. So that means that anything below 3 doesn't exist. So our composite function is that f of g of x equals x plus 6. But our restrictions are the domain is that x is greater than or equal to -3, and that our range, y, is greater than or equal to +3. And again, you could sketch this and figure out where x equals -3. G of f of x might be a little bit trickier because we have a different outer function. So g of x was root x plus 3. So we're going to go the square root of bracket plus 3. In the brackets, we are going to put f of x, which was x squared plus 3. And then we can go ahead and simplify this, and this will simplify to the square root of x squared plus 6. Now, again, we probably know what this looks like. We don't need a graphing calculator, but we could use one. If we want to go ahead and we want to sketch it by hand, this is square root of x squared plus 6. You know what, let's use Desmos for it. It's going to be a little bit easier. So square root x squared plus 6. Something like this. It's like a parabola, but it's been flattened off, and that's from our square root. Now, we do have a minimum value. X is greater than 2.45. But the question also is there any restrictions on x? if you look at the square root, x squared plus 6, that's never going to be negative because x squared can't make a negative and we're adding 6 to it. So there's no restrictions on x, and the range is that y is greater than or equal to 2.45. X is all real numbers, y is greater than or equal to 2.45, and our answer will be g of f of x equals root x squared plus 6, domain, x is in the reals, range, y is greater than or equal to 2.45. So then lastly, we need to use the table of values of f of x and g of x to find f of 2, f of g of 4, and g of f of 2. So f of 2, we just have to trace x equals 2 over to f of x. That's 0. And we're done. F of g of 4, we've got to first find g of 4. Go to 4. G of 4 is 2. So this is really like f of 2. And we know f of 2, that's 0. G of f of 2, we know f of 2 is 0. So this is really like g of 0. Go down to 0. G of 0 is 5. So we basically just trace the x value to our input, go over to the function we're trying to find, and then we can replace f of 2 or g of 4 with a number. We then work our way from the inside out to the next function until we've used up all the functions. So I think that's where I'll stop things. We've got a couple problems here, just something to kind of refresh your memory a little bit on what we had been working on. So we'll keep it short. I will see everybody tomorrow, and yeah, check your emails and I'll send out an invitation later today. Take care. Bye.